A lot of people know that the display is the most fragile part of a handheld. So what kind of design considerations do you do to make sure that the display is protected as much as possible?
The basic rule is glass is actually, amazingly enough, glass is very strong, but very brittle, as we all know. And glass is very sensitive to being bent, basically. A large flat sheet of glass, which is what a display is it doesn't want to bend. If it bends very far, it will break. So what you have to do is you have to protect the glass by not allowing it to bend. And so that's why in this old design we had these steel stiffeners back here, and we had the very stiff material for the case. That was so that the glass was constrained and really couldn't bend, right? It couldn't do this. It was really kind of forced to stay fairly flat. It's the edges of the glass that are really the critical part. That the middle can bow up and down, and that's not so bad. It can trampoline as long as the outside edges stay nice and square and straight. So we built this guy with steel stiffeners and a very stiff case. When we went to the Recon design, we added this stiffener, this chassis, and its purpose in life is basically it's very, it doesn't move much. It's very stout. Whereas, I don't have one. Oh shucks! I was going to show you how the outer case is very flexible, but this guy is very stiff and doesn't let it bend. We actually discovered through more testing of this design that we didn't need as stiff as we actually made it there. And so in the later Ranger X design, we actually eliminated this piece and got by with just the case halves. Right? There's just basically plastic and plastic here and the PC board. That's the secret there. There's one secret that we don't have, which is how do you stop something from breaking the display if you drop it on a rock and it lands right there, if something hits it right there. We don't have anything we can do about that, unfortunately, right now. When they do displays on flexible plastic, then that won't be a problem for us. But unfortunately, right now, displays you can get on flexible plastic don't have the characteristics we need for the rest of the system. So we're kind of stuck there.
So Jerry, we quote in our specification sheet, we quote that we meet MIL standard 810F specifications for ruggedness for all the temperature and altitude and drop by shock vibration. Well, we know it's really much more than just the spec. It's really about how our customers are using these units in the field and the kind of environments they're going to be working in. Can you give us an example of how you found that we exceed that spec and how we really keep the user in mind as we design and test?
Sure. A simple example, a real easy one, is the immersion test. The immersion test says that 1 meter underwater, unit is heated, if I forget, 18 degrees Celsius hotter than the water itself, etc. Right? In the water for an hour, half an hour, I forget which it is. And of course, we run that test and we pass that test. But what we do before that test is what really matters, in a sense, to the customer, because we run it through our temperature storage test first. And in the high temperature storage test, if the plastic is going to relax and move away from the seal in a way that causes that seal to leak, we run that test for a period of time which is long enough that in essence it simulates a lifetime for a product, say 5 years of room temperature stress relaxation takes place in a week at the temperature that we test them at. So in essence, what we've done when we run our version of that test is we've aged the unit so that it's in a condition it would be when the customer's been using it for 5 years, and then we dunk it in the tank and test to make sure that in fact it doesn't leak. It's not just a matter of passing that test, which you might be able to do with a material that would be totally useless in 6 months or a year. And in fact, I've seen many consumer products that advertise, that they're water resistant, and we're constantly tearing things apart to understand, how things are working, what's going on. And we've tried a number of materials, tested materials, in an attempt to make seals that would be, less expensive or smaller or easier to install or just, better in some other engineering sense. But what we found is invariably that the materials don't stand up. They'll pass the test if you run the test today. They won't pass the test if you ran that same test a year from now or 5 years from now. Ours will.
And that's when it really counts. So, Jerry, you've been involved with TDS for 9 years, 3 generations of handhelds, 2 entirely different platforms. Can you summarize for us some of the lessons that you've learned over the years, or some of the important things that you've done?
The first big lesson is that customers will do the most amazing things with your products that you and we're constantly learning from our customers kind of what really matters. Customers put our units in situations that we didn't expect them to be in, and when they pass, we're enormously relieved, and if they have a problem, then that gives us a new target, something to aim for, how we can make our products better. We have 3 generations of products here, and each one is better than the one previously. And I think it really comes down to just the fact that it really is a complete system, that you can't design one element and expect the system to work. You have to do the whole thing all together in an integrated design that takes all the factors into account. And that's very difficult, very challenging, and great fun.